Welcome again to the hardest questions challenge. This one here is from 2019, paper 3 higher. Solve algebraically the simultaneous equations x squared minus 4y squared equals 9 and 3x plus 4y equals 7. First thing to notice upon inspection is that the first equation is in terms of x squared and y squared. Now that tells you it's not linear, so it's not a linear graph if you to plot this as a graph. And the second one, 3x plus 4y equals 7, that is linear, so you can actually plot that as a graph. Okay, so that means that you can't use, because you've got x squares and y squares on the top and x and y on the bottom, you can't use the elimination method. So there's no point in matching up coefficients because there are no coefficients to match from equation 1 and equation 2, the one on top and the one on the bottom, because one is x squared and one is x, one is y squared and one is y. So what we need to do here is use the substitution approach. So what I propose that we do is we get from the second equation, we make y the subject and we form an equation in y which we then square and substitute into equation 1. So let's just label these 1 and 2 so I'm going to be consistent with what I'm saying to you, which is always good. So let's start with equation 2. If 3x plus 4y equals 7, what I'd like to do is get y as the subject, in other words the letter on its own, so I can then square it and sub it into equation 1. So if I take away 3x from both sides, I get 7 minus 3x on the right. Okay, and just 4y on the left. I then want to divide both sides by 4 to get y on its own. So I've got 7 minus 3x all over 4. I now want to square that to get y squared and ready to put that into equation 1. So I don't trust anything to chance here. So I'd much prefer using my grid to multiply out 7 minus 3x all squared. So basically I want to take all of that and square it. So 7 minus 3x is all squared, and the bottom is also squared as well, so I'm going to write that as 16. So I'm going to get 7 minus 3x all squared. So 7 minus 3x multiplied by 7 minus 3x. 7 times 49. Negative 3x times 7 is negative 21x. 7 lots of negative 3x is also negative 21x. Negative times negative is positive. 3 3s are 9. X times x is x squared. So that's going to be positive 9x squared. Collecting the x terms here gives me, I'm going to write from highest power of x first, 9x squared minus 42x plus 49. So my y squared equals 7 minus 3x all squared, which is this. So 9x squared minus 42x plus 49 all over 16. So now I'm ready to substitute the y squared into equation 1. So from equation 1, we have x squared, and here's the bit where we substitute the y squared in terms of x here. So x squared minus 4 lots of this, which is 9x squared minus 42x plus 49 all over 16. So x squared minus 4 lots of that, because that is squared already, equals 9. Now 4 and 16, 4 over 16 will cancel this down by 4. So this is now x squared. So we have up here, we have x squared. Let's just draw a little line there so you can follow. X squared minus 9x squared minus 42x plus 49 all over 4 now equals 9. Now, I'm going to multiply both sides by 4 to get rid of the 4 on the bottom of this second fractional term here. So that's going to be 4x squared minus all of this. So be careful here. We are subtracting all of this equation. So all of that denominator gets multiplied effectively by -1. So this is going to make the first term negative. The second term goes positive. So plus 42x, and the last term goes negative, so minus 49. Okay. Now remember, I've just multiplied this side all by 4, so I need to multiply this by 4 as well. The right hand side, that's 36. Okay, 4x squared minus 9x squared is negative 5x squared. 42x, well, there are no other x terms to add or subtract, i.e. collect with that. Negative 49 on here on its own, and positive 36. So I want to get this as 0, so I need to subtract 36 from both sides. So minus 49 subtract 36, so 49 and 36 is 85. That then equals 0. So what I've done there, just to reinforce that, I've subtracted 36 from both sides because I want one side to be 0, because then I can input these values into the quadratic formula. That's the one I'm going to head for. Okay. So I need to solve effectively negative 5x squared plus 42x minus 85 equals 0. So I'm now going to invoke the quadratic formula. So remember, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So from the top here, a is negative 5, b is 42, positive 42, and c is negative 85. So let's go ahead and substitute values in. So the negative of b means the negative of 42, negative 42, plus or minus the square root of b squared, that's 42 squared, minus 4 lots of a, so that's 4 lots of negative 5. And I like to keep the 4, the 8 and the c separate so I don't make an arithmetic mistake. 4ac, so the c is negative 85 all over 2 times a. Well, 2 lots of negative 5 is negative 10. I'm okay mentally to do that. So that gives us negative 42 plus or minus. Now I'm going to take care on the calculator because it's calculator paper. So I'm going to work out 42 squared. Actually, no, what I'll do first of all is just, I'm going to multiply 4 by 5 by 85, and it's negative, negative, negative. So actually, just thinking about this on the fly, I'm going to break this down into 2 steps. 42 squared is 1764. 1764. I'm going to multiply 4 by 5 by 85. So 4 5s times 85 is 1,700. I'm going to write that down there. I'm going to make sure I get the right calculation here, the right operator between those two numbers. Now this is a negative times a negative is a positive, so I'm subtracting a positive value, so it's going to remain as subtract. Okay, that's all over negative 10. So I think you see therefore you've got negative 42 plus or minus 1764 minus 1700 is 64. Square root of 64 is 8. So it's that and that. Okay, so either x equals negative 42 plus 8 all over negative 10. So negative 42 plus 8, negative 34, divided by negative 10 is positive 3.4. Okay, or x equals negative 42 minus 8 all over negative 10. Negative 42 take away is negative 50. Negative 50 divided by negative 10 is going to be positive 5. So that's half your solutions, because remember we have an xy pair that we're seeking here. So we need a solution for x. For every value of x we have a solution for y. We have two x values, so therefore we need to line up two y values for them. So what I simply do here is substitute the x value into our rearranged formula for y, which is this one here. So again on the calculator, I'm then going to write, so I've got 3.4, so 7, or rather fraction button, on the top, 7 minus 3 lots of 3.4, all divided by 4. That's going to give me negative 4/5, and I've written my first value as a decimal, so I'll keep in the same format. So with x is 3.4, y would be negative 0.8, and if x was 5, the corresponding value of y is going to be 7, so fraction button, 7 minus 3 times 5 all over 4 gives me negative 2. So two pairs of values, x equals 3.4 with y equals negative 0.8, and x equals 5 with y equals negative 2.